Yeah. So why do we need to classify the elements? Tell me first. Because to have some clarity on the elements. See, in early days we only know very few elements, but later on the elements are keep on adding. It is very difficult to remember all those properties, right? So something like if you go to a library, the books are arranged in a very very properly. I mean, whatever the book I want, I will go to that side and I can take it. Like if I want a chemistry book, I can go to that wing, I can pick out. So similar to that, if we arrange the elements based on their properties, it is easy for us to study their chemistry, right? So that's why we have different approaches to classify the elements. So what is the first approach to classify the elements? Daubernier's triad. What is it? Daubernier's triads. So how he classified, tell me? Yeah. So very simple. So Daubernier means presently how many elements we have? 118. But at that time very few elements are known, like around some 30 elements, like that we have. So now what he considered is, whatever the known elements are there, some elements he taken from it and he arranged based on the increasing of atomic weights. See, let us say A, B, C are 3 elements. A, B, C anevi oka 3 elements anukondi. He arranged these 3 elements on increasing order of atomic weights. What? Atomic weights. Now these 3 elements kada, what is triad anadu? What is the name? Triad. So you just remember it as Daubernier's triad. Okay. So 3 elements, set of 3 elements are arranged in the increasing order of their atomic weights. Now the atomic weight of middle element is an average of first and the third. So what I am saying, atomic weight of middle element, that is B, is equals to atomic weight of A plus atomic weight of C by 2. So this is how he classified the elements. Okay. Now what are the things he taken? So the first one is, you just remember first group elements we know now. What are those? Lithium, sodium, potassium. So he taken this as one of the triad set. Okay. You just remember it as LINAC. Okay. Next one, calcium, strontium, barium. Okay, just remember it as CSB. What is it? CSB. You know CSK, like that you just remember it as CSB. Okay, this is one more triad. Next triad is chlorine, bromine, iodine. Just remember it as CBI or whatever the way you want. So it is CBI, it is CSB. So why I am saying like that means, after few more days you may get confused, like the triad means magnesium, calcium, strontium, or calcium, strontium, barium. This kind of confusion will be there. Just remember now, this also starts with C, here also starts with C. So it is CBI, it is CSB. Okay, and this is LINAC. So these 3 important triads are there. Okay, so now what does it mean? Triad means what? The atomic weight of lithium plus atomic weight of sodium average will be equals to lithium, potassium average atomic weight will be equals to sodium. Okay, let us see that. Something like this. Okay. See, just add 39 plus 7 by 2, 46 by 2. So it is 23. So we are getting the middle element mass now. So like that. So these are the 3 set of element triads we have right now. Okay. So the next, what is the drawback of his classification? See, first thing is, there are very few elements at that time. And the drawback is application, like this triad set is he given only for few elements, not for all the known elements. It means only few elements, not for all elements, means it is not at all perfect one, right now. So it is got failed. So just remember, what is the drawback? So he could not able to arrange all the elements known at that time into triads. And remembering triads also difficult thing, like 3 elements, it is also difficult thing. So therefore it got failed. Okay. So the next one, Newland's law of octave. What is the name? Okay, so Newland's law of octave means, so name itself saying no octave, it means you take 8 elements, 8 elements. So for every first element and the 8th element, there will be similarities in the properties. Okay, so this is set of 8 elements. Okay, for every first and 8th, there is a repetition of properties. So like that, in 1865, Newlands arranged the elements in the increasing order of atomic weights. Okay, and this law is applicable only for lighter. See, when the lighter elements were arranged in the increasing order of their atomic weights, the properties of every 8th element were similar to that of first one. Okay, first one. So which and which? First and 8th. For example, if you take lithium here, so lithium is having similarities in properties with the 8th element, that is sodium. Okay, so here it is 3, it is 11. So difference is 8. So every first element, 8th element. Like that they will ask, which are the following elements have similarities in properties, or which are the following elements obeys Newland's law of octave. First thing is, it is applicable only to lighter elements, and you just remember it is applicable only up to 20. So 20 means calcium. After that it won't be suitable. Okay, therefore it is got failed. Why? It is applicable, like this one is valid only for up to calcium and fails in case of heavier elements. Okay, next line. When the noble gases were introduced, it means what? When Newlands given his octave concept, noble gases were not discovered. Later it got discovered. So now what happens if we insert a noble gas here? That 1,8 become now, previously it is 1,8. Now by insertion of noble gas leads to 1,9. Previously 1,8, now it becomes 1,9. Why 1,9? Because noble gases is inserted there. ఇంతకు ముందు ఇక్కడ నోబెల్ గ్యాసెస్ ఉందా? లేదు. చూడండి, సి ఫ్లోరిన్ తర్వాత మనకు నియాన్ రావాలి, ఉందా? లేదు. ఇఫ్ ఇన్సర్ట్ నో ఇట్ బికమ్స్ 9th, దట్ ఈస్ సోడియం బికమ్ 9th ఎలిమెంట్, రైట్? సో 1/9 it becomes, just remember that. Okay, that's it. So what is the failure? It is applicable only for first 20 elements, lighter elements, that's it. Next, Lothar-Meyer curve given for elements. Okay, again what he did, he taken a graph atomic volume versus atomic mass. This is important, they will make questions like this. See, ఇక్కడ నుండి అసలు క్వశ్చన్స్ ఎలా వస్తాయి సార్ అని అంటే, జస్ట్ సింపుల్, what is the fundamental concept he considered to classify the elements? Daubernier, Newland's law of octave. He just arranged the elements in the increasing order of atomic weights, and they are applicable only for lighter elements, like that we have seen. When it comes to Lothar-Meyer, he arranged the elements by taking atomic volume versus atomic mass. Okay, and he drawn the curves. So on these curves, those elements having similar properties occupies similar positions. Occupy similar positions means what? See, all alkali metals will have similarities in properties. Alkali metals ఏంటి? Lithium, sodium, potassium. Now all this potassium, rubidium, cesium, all these elements will have same positions or similar positions on the curve. So similar positions means, see, at the top of these curves, at the top of these curves, if you observe what elements we are seeing, sodium, potassium, rubidium. So at the peak of the curve is occupied by alkali metals. So in the exam మనల్ని అడిగే క్వశ్చన్ ఇక్కడ నుండి ఏంటంటే, so alkali metals where they will be on the curves at the peak. Okay, next, if you see where the noble gases will be observed in the curves, just look, see, just below the, just below the or just before the alkali metals we will be seeing noble gases, like here argon is there, okay, and here krypton is there, okay, and just before that you can see halogens. Okay, now just remember, if this is a peak going like this, at this top who will be there? Alkali metal. Let us fix it as sodium. Okay, now you know ascending, descending. Ascending means what? Small to big. So this is increasing curve or ascending curve, can I say? Increasing or ascending. Now the simple term they will use, halogens will occupy ascending curve of the peak. Will you accept the statement or not? Once again, halogens will occupy ascending of the curve. Ascending means increasing order only, no? Yeah, so here halogen will be present. Yeah, it is true statement. Even noble gases also occupies ascending peak of the curve. So these kind of statements, like what are the statements you will see in the exam means, just read these 4 statements. Alkali metals such as potassium, rubidium, sodium, which have similar properties, occurs at the peaks of the curve. We already seen. Next line you just read halogen elements like fluorine, chlorine, bromine, which have similarities properties, will be occurring at the rising of the curve. Ade increasing annam kada, increasing of the curve or ascending part of the curve. Next, ఇది చూడండి, noble gases such as neon, argon, krypton will have similar properties are just before alkali metals, just before alkali metals and just after halogens in the ascending order of the curve. Okay, next, hydrogen and helium are exception to this rule. Which rule it is? Luther-Meyer curve. Okay, so you can also observe the story in case of graphs also. See, hydrogen, helium should not be here, helium should be somewhere over here. So that's why it is an exception, he is saying. Okay, now tell me, remembering their dots, I mean remembering the curves, I mean points on these curves, it is also very difficult, right? So now just imagine 118 dots you need to remember now. How difficult it is? Okay, so this is also got failed. Okay, right. Next, who is next? Mendeleev. How he given the classification? At that time it was around 63 elements known. How many elements are known? 63 elements. He arranged these 63 elements in the increasing order of their atomic weights. And you know, his classification is one of the best classification. Why? Because all these 63 elements he just like subdivided or properly classified as groups and as periods. Groups and periods. Who is the person? Mendeleev. How he arranged the elements, 63 elements in the increasing order of their atomic weights. Now read this line, the physical and chemical properties of elements are periodic functions of their atomic masses. Okay, so this is Mendeleev's periodic law. So they will ask what is a Mendeleev periodic law means. You just remember it as atomic mass first. Okay, then you can get that line. Okay, so at that time how many elements were known? 63 elements known. Okay, so now he told, I think you know, these horizontal lines are called as periods and these vertical columns as groups. Okay, now he told there are 7 periods. How many periods? 7 periods. How many columns like this means? He taken 8 groups. How many, like this vertical columns are then vertical lines, those are groups. How many groups he given? 8. So these 8 groups again further classified as A and B. Once again 7 periods, keep it aside. Next 8 groups. So these 8 groups again classified as subgroups as A and B. So like 1A, 1B, 2A, 2B, like that up to 7. Up to what number? 7. Like 7A, 7B. Okay, then what about 8th? So this 8th group he taken set of 3 rows, I mean 3 columns like this. So 8th group contains 9 elements together. How many elements in 8th group? 9 elements. I will show you that. Okay. So once read these lines. Vertical columns were called as groups and there were 8 groups in Mendeleev periodic table. Each group up to 7 is subdivided as AB. Okay, A subgroups are called normal elements and B subgroups are called as transition elements. Ante, you know, like starting these 2 groups we will say it as S block elements right now. Okay, so these are considered as A subgroups and P block elements are there now. So those are considered as also as A subgroups like 1A, 2A let us say. This is 3A, 4A, 5A, 6A, 7A. And the last group if any noble gases, that is 0. But that time noble gas is not there. Okay, and in between what we'll get here? D block elements, transition elements will get now. So for them he given it as 1B, like copper given as 1B, zinc given as 2B, then next here scandium as 3B, 4B, 5B, like that. So now here we will get iron, next cobalt, nickel. After nickel we get copper, the next zinc. So this iron family, cobalt family, nickel family elements are there now. So this set of 9 elements he considered as 8th group. Which group? 8th group. ఒకసారి మళ్ళీ చెప్పండి అమ్మా, మనకి మొత్తం ఎన్ని గ్రూప్స్ ఉన్నాయి? ఈ 8. ఈ 8 గ్రూప్స్లో ఎలా డివైడ్ చేశాడు? ఏ అన్నాడు, బీస్, ఏస్, బీస్. ఈ 8 గ్రూప్లో నెంబర్ 8ని పక్కన పెట్టండి, ఇంకా 1 to 7నే ఏ బీస్ లాగా తీసుకున్నారు. సో 1A 2A ఎస్ బ్లాక్, 3A to 7A, like consider this side as P block, just for understanding purpose. All B's comes for D block. Where exactly it starts? For copper it is 1B, zinc it is 2B. The next the scandium family, next scandium titanium family 4B, titanium 4. Next vanadium 5, next vanadium chromium 6, next manganese 7, B's 6B 7, these are all should be B's only. Next this completely this ferrous, cobalt, nickel as 8th group, and these 9 elements we should call as transition triad. What is the name? Transition triad. See, we definitely think this chapter is little bit easy or boring or something like that, but the questions are this terminology they are using now, which of the set of elements are considered as transition triads. What you can say? Ferrous, cobalt, nickel groups, like set of how many elements? 9 elements. Yeah, that's it. Next. Okay, so now what is the merits of Mendeleev periodic table? Yeah, so Mendeleev, what he did is, in his classification, when he is giving his periodic table, he left some space. What he did? He left some space. For what purpose he left? So he predicted some elements, like he assumed that, yeah, if I left this space here, in future some other scientist may find element that exactly fits here. Like that he left some spaces. It means I can say he predicted few elements. So prediction of new elements were done by Mendeleev. So what are the predicted elements? These are the predicted elements. So now just remember Eka, like Eka, aluminium. See, aluminium is known at that time, but for gallium is not known at that time. So in future gallium may be discovered that fits at this particular position. Like that he named it as Eka aluminium and left the space. Later gallium got discovered exactly fitting into Eka aluminium space. Okay, now in the exam you just need to remember like this. Eka aluminium means which element? Gallium. So just remember here, aluminium, what is the 2-letter word? I mean first 2 letters? Al. So gallium, second 2 letters, see once? Al. So now like that you can remember, no confusions. Next one, Eka boron. Okay, Eka boron means, you know boron electronic configuration? Boron 5, no? 1s2, 2s2, 2p1. Scandium kuda rayandam okkasari. 4s2 valency, 4s2, 3d1. So how many valency electrons are there? 3. Here also 3. So why I am saying this means not to have any confusions. So boron has 3 valency electrons, scandium also has 3 valency electrons. So just remember it in that way at least. So what do we mean by Eka boron? Scandium. Next, silicon. So you know carbon family, tell me. Carbon, silicon, germanium. So below silicon we have germanium. So silicon, germanium, it means Eka silicon is nothing but our germanium. Last one, Eka manganese means technetium. Once again, Eka manganese, technetium. Okay, right now tell me again. I just want to Eka Ica, aluminium, gallium. Next, Ica, boron, scandium. Ica, silicon. Next, Ica, manganese. So you will remember now. Okay, nothing to feel difficult. Priyansh. Okay. So now what is the demerits of Mendeleev table? See, what is the basic fundamental thing he considered in his periodic law? Atomic weights. Now if atomic weights are considered, see, we know carbon has different isotopes. What are the isotopes we have? C12, 13, 14. See, if the atomic mass is fundamental thing, carbon C12 has to give separate position, 13 has to give separate position, 14 should be placed separately. But all these elements, all the carbon elements are placed at one position only. And the drawback annatte kada. So what I am saying is, periodic table ela arrange chesaranta, increasing order of atomic weights annaru. So ఇప్పుడు atomic weight different ఉన్నాయి కదా మరి isotopes కి. If isotopes having different atomic weights, they should have different positions in the periodic table. But all the elements are placed at one position only. Means this is a drawback or not? Yes. So just remember, position of isotope is not at all satisfied in Mendeleev periodic table. Next, position of hydrogen is also not at all satisfied. Okay, next. There is something called anomalous pairs. What is that? Anomalous pairs. So you just remember, anomalous pairs is nothing but, see, మనకి ఏం తెలుసు, అటామిక్ ఎలిమెంట్స్ని ఎలా అరేంజ్ చేశారు Mendeleev periodic table లో? In the increasing order of atomic weight. అంటే first there should be lower atomic weight, then next higher atomic weight, right? First lower, then next higher. Now see, argon and potassium. Just check the argon atomic mass, 39.9. Potassium atomic mass, ఎవరు ముందు రావాలి? 39.1 is smaller number now. So first potassium, then next argon. But ఇతని టేబుల్లో ఫస్ట్ ఆర్గాన్ వచ్చిన తర్వాత ఇతనేమో ఐ అరేంజ్డ్ బేస్డ్ ఆన్ ఇంక్రీజింగ్ అటామిక్ వెయిట్ అన్నాడు. అప్పుడు ఎవరు రావాలి? పొటాషియం రావాలి. బట్ ఎవరు వచ్చారంట? సో వై లైక్ దట్ అంటే అతని దగ్గర ఆన్సర్ లేదు. సో ఇది కూడా డ్రాబ్యాక్ అనుకోవచ్చు కదా. సో దిస్ ఈజ్ ఆల్సో వన్ డ్రాబ్యాక్. So this kind of scenarios are considered as anomalous pairs. Okay, so now what are the anomalous pair elements from the given set, they will ask. So first anomalous pair is argon and potassium. Next anomalous pair is nickel and cobalt. And next anomalous pair is iodine and tellurium. Just remember them. What are the three pairs? Argon, potassium, nickel, cobalt. That's it. Next, so drawbacks, advantages over. What is the main advantages of Mendeleev? Prediction of future elements, like in future. Yeah. Next, drawback, anomalous pairs, isotope position, hydrogen atom position. These are the main three drawbacks. Okay. Next, periodic table. So modern periodic table is given by Henry Moseley. So what he considered in 1913. So what he considered is, if this is an element, he bombarded this element with some X-rays. What is that? X-rays. Now this element will absorb some energy and it will emit some energy, right? Okay, so that emitted frequency will be there now. So he drawn a graph for emitted frequency versus its atomic number. What is that? Atomic number. Then he found a graph something like this. See, what is mean by Z here? Frequency. This V means frequency. Here it is atomic number. See, if I go this side, what happens to atomic number? Increases. So atomic number, as atomic number increases, this frequency also getting increases. Like this, he got a straight line. Okay, so now based on this observation, he given the periodic law. Okay, now Mendeleev ఎలా క్లాసిఫై చేశాడు, based on atomic weights. So he observed the graph for even atomic masses also. Atomic masses తో అబ్జర్వ్ చేస్తున్నప్పుడు he observed the graph something like zigzag. Okay, then he just removed it and he considered with atomic numbers, then he got a straight line. Okay, so straight line ఎందుకు వచ్చింది సార్ అంటే, as number of protons increases, emitted frequency also getting increasing. So like that he observed. So finally what he told, the physical and chemical properties of elements are periodic functions of their atomic numbers. It is previously atomic weights. Okay, just remember this line. Okay, next. Okay, so now what are the main characters of modern periodic table, the present periodic table? So it has 18 vertical columns, we are calling them as groups. Okay, and now next 1 to 8 groups and also one zero group. That zero group is nothing but our inert gases. So inert gases were introduced into the periodic table by Ramsay. Inert gases were not there in case of Mendeleev, but in modern periodic table we have this. Who introduced them? Ramsay. Okay, now 7 horizontal series are called periods. Okay, see, you should not ignore even any single line from NCERT first. Okay, so periodic table మీరు ఏం చేస్తారనంటే, either our modules or go to the NCERT line by line, just underline everything. Okay, whatever you feel it is important, you just make a note of it. Okay, complete periodic table you should make one sheet of paper. ఒకటే షీట్లో మొత్తం పీరియాడిక్ టేబుల్ గురించి మొత్తం ఉండాలి. ఓకే, అప్పుడు ఏమవుతుంది, ఫస్ట్ టైం చదివినప్పుడు ఎక్కువ టైం తీసుకుంటుంది, బట్ నెక్స్ట్ టైం వెన్ ఎవర్ యు ఆర్ రివైజింగ్ ఇట్ హ్యాపెన్స్ ఇన్ విత్ ఇన్ సమ్ హాఫ్ అన్ అవర్ టు 1 hour టైం. Okay, first revision may take 1 hour time, second revision it becomes half an hour, next it can be happen in 5 to 10 minutes only. Okay, so that much effectively you need to make your short notes from starting onwards, not only for chemistry, for any subject. Okay, yeah, next. Page number 73, question number 1 to 10. Just check. వచ్చినాయా? ఇప్పుడే చదివాం కదా, లోథర్ మేయర్ కర్వ్ ఎక్కడ ఉంటుంది పొజిషన్ ఆఫ్ ఆల్కలీ మెటల్స్? పీక్స్. నెక్స్ట్ లైన్ కూడా చూడండి ఒకసారి, దాని ఆన్సర్ చూడండి ఏముందో. ఆల్ అని ఉంది కదా, మరి నెక్స్ట్ స్టేట్మెంట్స్ కరెక్టా కాదా చూడండి. జనరల్గా మనం ఏమనుకుంటాం, ఆల్కలీ మెటల్స్ ఎట్ ద పీక్, దట్ ఈస్ కరెక్ట్ ఓన్లీ. బట్ వీ నో ఇన్ కంప్లీట్ పీరియాడిక్ టేబుల్ విచ్ హ్యావింగ్ మోర్ మెటాలిక్ క్యారెక్టర్, which elements are having more metallic character? Like S block elements, as we move from here to here, what happens? Metallic nature decreases. So S block elements more metallic. So that is correct only now. Highly electropositive elements will occupy peak of the curve in Lothar Meyer. It is correct. Next, elements having larger atomic volume. I hope you know, size from left to right, what happens? Decreases. Left to right, size decreases in periodic table. So who is at last, left side of the table? S block, that is alkali metals. So it means that is also correct, they will only occupying the peak of the curve. Okay, so all of the statements are perfect. Next question, that we haven't discussed. Okay, no issues. Go for 9th and 10th question. 8th, 9th, 10th. Which of the following set of elements obeys Newton's octave rule? Newton's law of octave applicable to what? మనం ఏమని చదువుకున్నాం, న్యూలాన్స్ లా ఆఫ్ ఆక్టేవ్స్ అప్లికబుల్ ఓన్లీ ఫర్ elements names also now. 101, what is the element we have? Mendelevium. 102, 103, 104, 106, 106, 105 is okay. 104 is Rutherfordium. 105 Dubnium. Next 106 Seaborgium. Okay. 107 Borium. 108 Hassium. So why we are studying like this means you just try to answer this question first. See, Mendelevium, what is the name number we got? 101. So suitable answer for that. Nil, Nium. So A1. Next, Laurentium. Seaborgium. Match it. So first try to write this in the very short and fast manner in your notes, otherwise. Just use the symbols otherwise. 106 Mendelevium symbol, like that you make a short note. Harshavardhan, I think my voice is clear now. Once check. Okay.